Hey class, welcome back to chapter 4. Today we'll be looking at exercise 4D, multiplying algebraic terms. So we can write multiplication of algebraic terms in either expanded or simplified form. When we multiply terms with the same pronumeral, we'll use what's called index notation to simplify. We have looked at index notation before, just not with pronumerals, okay? For example, a times a times a, we've multiplied a by itself. There's 3 of them, so a to the power of 3. Okay, a few examples for you today. Now, in our previous exercise, we could only add or subtract like terms. Today, we're looking at multiplication, so we can collect all of the terms. What we have here is 6 times x times negative 2. Okay, that's expanded. We're going to simplify it now. What we'll do is we'll take the 6. Let me grab a highlighter actually. We'll grab the 6 and the negative 2. 6 times negative 2 is, of course, negative 12, and the x stays with it, so negative 12x. Remember as well that when we write multiplications, we don't have to write times x, we can just say negative 12x. It's the same as saying I've got negative 12 groups of x. I've got 6 times whatever x is times negative 2. Let's try another. 3 times a times b. So again, all we're going to do is get rid of these multiplication signs, and we write it as 3ab. I like to write them in alphabetical order. Of course, if you want to write 3ba, go for it. It is exactly the same thing because it does not matter what order you multiply in. Okay, if I said 2 times 3 is 6, 3 times 2 is still 6, doesn't matter if I flip the numbers. Okay, so either of these are the same, does not matter. Do not panic about that. All right, a little bit trickier now. We have 4CD times 9DE. What you'll notice is that we have 4 times 9, okay, and this is basically saying 4 times C times D times 9 times D times E. 4 times 9 is 36, and I'm going to write the rest out in expanded form just to show you what's going on. Got a times C times D times D times E. Okay, what you'll notice in the middle now, I hope, is that we have 2 D's, okay, which we can simplify using index notation. We get 36. We're going to keep the C. We'll keep them in order. D, we've got 2 of them, so that's D squared. D times D is D squared, or D times itself. And E. You can of course write that in any other order, E, C, D squared, C, E. It does not matter what order these variables in. What matters is that that D squared, that squared belongs to the D. Okay? Please don't put the 2 on any other number in this particular example. Last one now. 4x cubed times 5x squared. Now, again, I'm going to grab my green highlighter. 4 times 5 is 20. Okay, so that's a nice easy one that we can jump straight to. We work with the coefficients as they are. And now what we have is effectively x times x times x. So that's the x cubed from the beginning. And then we're going to multiply by x times x. So this first group came from the first x cubed, okay, those 3, and this x squared we've expanded out to these x times x. What you'll now notice, I do hope, is that we have 1, 2, 3, 4, 5 x's multiplied by each other. So to simplify that, and this is what we'll introduce more thoroughly as index laws next year. We'll keep the 20, put the x down because we don't need to write this multiplication symbol, and we've got 5 of them. This is an index law. What you might notice as my final point for today, thank goodness, is here we had 3 and here we had 2. 3 plus 2 is 5. Okay, we had 3 plus another 2 gives us 5 x's. So the index law that is really, really useful for this particular exercise is that if I have some power a and I'm multiplying that same base number x by another power of b, then my power is a plus b. And we have looked at index laws before. Okay, we looked at them in our earlier chapter when we looked at powers, indices, and index laws. This is just using an algebraic base. So instead of it being like 3 squared times 3 cubed is now 3 to the power of 5, that 3 has been replaced with the x. Okay, so this is your first index law. It's usually written with different letters and things like that, but that's fine. Okay, I think I've given it to you in the past as this is exactly the same. I've just swapped the x's with the a's. Okay. So this is the index law. This is what's usually written, okay? In this particular case, what we've got, if I demonstrate it one final time, okay? In general, we're adding the powers, and I can't stress this enough because it does pop up again early next year. X to the power of 3 times x to the power of 2 is the same as saying 3 plus 2, okay? So that's just what's going on up there, okay? And that's the index law that you will need to know for this exercise. As always, guys, if you have any questions, please feel free to get in touch. But otherwise, good luck with the work, and I will speak to you all very, very soon.